So now that you've had a chance to solve through those, a couple ones, it's pretty simple for us to kind of see how to solve these out. Now, when we look at this first one, right, we know our ratio is 1 to 1 to the square root of 2. Right, so this number 8 here is something to the square root of 2. So to get back to the square root of 2, we'll have to divide by both sides. Well, we can't do that, so we need to multiply that out. All right, and once we do that, we are left with 8 square root of 2 over 2, because a square root times a square root is basically a square root squared, so it is just the number with nothing else. Simplify that down to 4 square root of 2 as our answers for these two sides here. And that's just simply using our basic formula. Now for this one, it's going to be 1 square root of 3, 2 as our solution here. And we need to go forward and kind of look at our sides here. So this is our 1, this is our 2, and then this is our square root of 3 side. So you can already see the square root of 3 there, so if we need to get away from that side, what we'll have to do is divide by the square root of 3 on both sides, and they'll cancel each other out. But basically, you can just know right off the bat that that side's going to be 4. That's our one side. Our ratio says that this side here is going to be 2 times that side, so we know that that's 8. And we've solved 2 special right triangles in a matter of moments. All right, we get down to this bottom one here. It's just a distributive property to start. So I didn't touch the 3m minus 6m equals negative 24m plus 6, and distribute again. Right, we get a minus 3m minus 6. All right, now I want to go through and I want to find my like terms. So here's my first set of like terms. Here's my second set of like terms. So what I'm left with over on this side here is I have 3m minus 6m. It's going to be negative 9m. And that's going to equal negative 24m minus 3m is going to be negative 27m. And that's going to be 0. So when I go to combine, do my next step here, add 9m to both sides, I've got 0 equals negative 18m, m equals 0, because it can't equal anything else. All right, so hopefully that kind of helps you guys get going today. As we do that, I did give myself more room. I knew I should have used it. Anyways, just kind of a refresher about our special right triangles. When we see a 45, 45, 90, the two sides are going to be, the two sides that are adjacent to the right angle are going to be on a 1-to-1 ratio. They're going to be the same thing every single time. And then the hypotenuse is going to be that one side multiplied by the square root of 2. And that's all you have to remember. So it gets a little difficult when you go back away from it because you have to divide and you've got a lot of math. But it's pretty straightforward there. All right, next example here would be the 30, 60, 90 triangle. And what we do with that is, again, our short side, our side opposite the smallest angle, the 30-degree angle, is going to be 1. All right, our 60 side is going to be that one side there times the square root of 3. And then our final side is just going to be 2 times that one side. And that's how we try to remember that. So what does that look like? That looks something like this as we kind of work through it and see what it looks like as you guys work through. And we'll do some examples of this because I think it's really important that we do some examples. All right, for instance, on this one, here we go. When we talk about special right triangles, right, we have our 60-degree side here. So we know that this is going to be square root of 3. And our ratio, we know that this is going to be 1, and we know that this is going to be 2. So when I go to solve this, it's pretty simple, pretty straightforward. If that's 1, right, 4 is going to be, a is going to be half of 4. So all I have to do is take 4 divided by 2, and I am left with 2. So a equals 2. Now, this is going to be this number times the square root of 3. So I know that 2 square root of 3 is my side here. Now, if you want to take the time and check me on the Pythagorean theorem there, you guys are more than welcome to take the time to check me on the Pythagorean theorem. But I'm going to tell you that as long as you guys are applying that correctly, it's going to work out just fine. It's going to be the same thing that you guys just saw me do. All right, so it's going to equal that out. Here's another example, right? So we have the hypotenuse again. Let's find our sides. Here's our 1 side. Here's our square root of 3 side. And here's our 2 side. So we have to take that 2 side, divide it by 2 to get it to there. So we're left with 5, and then 5 times the square root of 3 here. All right, and again, I'm solving these so quickly. It's just simple mental math. I don't even get my calculator out because I'm not even trying to break away the radicals. When we talk about a 45, 45, 90, we're talking about them having the same. The hypotenuse is just the square root of 2 times the leg. And what that looks like is, okay, so we've got our side. Here's a 1 side, here's a 1 side, and here's the square root of 2 side. So what do I have? I have 5, so we know that this is going to be 5. And we know that this side is going to be 5 times the square root of 2. Now if you want to prove this, 5 squared plus 5 squared equals x squared. And in this case it's really y, so why don't we use y? All right, so 5 squared, 25, plus 25 equals y squared. 50 equals y squared. Take the square root of both sides. This can factor out to 25 times 2. That's our highest perfect square, equals y. Square root of 2 times square root of 5 equals y is our final answer. So you guys can see it. It's there. It works. It's simple. Same thing up here, right? So here's our 16. We know this is a square, so we know that these are all going to be 16 here. And that basically helps us a lot. So now all we have to do is say, okay, well, what this is 16 square root of 2 is our final answer, because this is a 1, this is a 1, and this is square root of 2. And that's how you solve it. Right? So looking forward, looking at today a little bit more in depth, we're going to start talking about those trigonometric ratios. And what I want to do is I want to just kind of show you guys how to do everything that we're going to be doing this week with them. This is where we kind of started, and you guys were really good at this. It was a practice in identifying, not so much a practice in math. So you would identify this is x, they want the opposite, right, over the hypotenuse. So here's our hypotenuse right here, so we would go 40 over 41, right? Same thing with this. We'd want the adjacent to A, which is our 7, over our hypotenuse, which is our 25, so you guys would write 7 over 25. Last but not least, we have our tangent of z here, right? Here's our z. So the opposite, 9 over 40. And we are done. You guys were really good at that, minus the simplifying of the fractions. Now in this case, they're all simplified, so we don't have to worry about that. So looking at the other ways that we're going to use this is I'm going to jump ahead here for you. And we're going to look at both the inverse and how to find the missing side. So we're going to look for angles and we're going to look for sides. So bear with me. All right, so here we are. We have two problems, and these are problems that deal with the so part of our whole thing. So we're going to be looking for the sine here. All right, so we have two sides, and we have two different ways of going about it. And I'm going to actually help by writing the calculator functions out for this. First one we're going to start with is the one on the right. The one on the right gives us this example of the hypotenuse, and it gives us x, which is the opposite side of 62. So when I go to plug this in and look for my solution, right, I know my hypotenuse is 18. I know my sine is what I'm looking for, and I know my degree measure. So I should come up with a side of about 15.8. So again, how that works is I have my again, first and foremost, we're looking at the opposite here over the hypotenuse right here, all right? And what I have is I have a distance here, so what I'm going to plug into my calculator is just simply 18 times the sine, sine of 62 degrees. And when I plug that out, I come out with 15.89305667. Now I don't need to deal with all that. Most of the time it's going to ask us to round to either the whole length or the nearest tenth, maybe hundredth. So all I have to do is focus on this with paying attention to that. So that tells me I'm going to round up, so that tells me that my answer here is 15.9. All right, jumping over to the other side here, well, I'm not really given an angle measure, so what do I have to do? This is where what's known as the inverse comes into play. So we're going to use the sine inverse to help figure this out. All right, so again, we have our opposite here over our hypotenuse here. So what we have to do when we go to our calculators, we just have to go second plus sine, which would actually be sine to the -1, All right, so once I get second sign to the -1, I'm going to put in exactly what I have here. I have 32 over 35. So now I'm going to go 32 divided by 35. I'm going to close my parentheses. So this is what it should kind of look like. Let me get that. Close my parentheses and hit enter. And what I'm going to come up with is 66.10449181. Now again, I only need probably one digit, so what I'm going to do is I'm going to focus on that second digit, and I'm going to come back with 66.1 as my answer for this one. All right, so that's how you'd use the inverse for a sine equation. Next, when we talk about Alright, so when we take a look at these next trigonometric ratios, what we're going to be looking at is we're going to be looking at the cosine or the ca side. Remember that this is really adjacent over hypotenuse. And when we look at this first one here, right, we're looking at it, and here's our hypotenuse. So our cosine here is this 10 over x. That's really difficult for us to solve, and since we're looking for that side, what we have to do is plug it into the calculator. And how do we plug that into the calculator? So here's what this kind of looks like. Cosine of 27 degrees equals 10 over x. So the first step we should do is multiply both sides by x over 1. And once we do that, we're left with cosine 27x equals 10. I'll divide each side by cosine 27, cosine 27. And now you have something you can actually plug into your calculator as follows. 10 divided by cosine 27. And that should equal out to our length of the hypotenuse, which again would be cosine 27. Plug that in and become out to, let me do that right. I did that wrong on my calculator here. I need to divide by 10, not multiply cosine 27. All right, and that's a mistake that you may make the first couple times, and it's 11.2 after I round. So it's approximately 11.2, not exact. We come over here, we have to use the inverse, right? So here's our adjacent side, and here's our hypotenuse. So we come up with 32 over 44 as our cosine. So what we have to do is we have to hit that second button again, all right, plus that cosine button, which should display something cosine -1. And in there, we're just going to put 32 over 44. And by doing that, we're going to come out to a pretty long fractional. And as long as your calculator's in degrees, which it should be, you will have no problem rounding to the nearest tenth to solve for this. So what you see there is you see 43.34. And I'm going to stop right there, 43.34, because I only need to go to the nearest tenth. So this is the important digit. This is that digit that's I'm going to look at. It's not telling me to go up, so my final answer is 43.3, and that is degrees. So once you work through that, you can kind of see how everything flows with the ka part of SOHCAHTOA. Last but not least, we're going to take a look at the TOA part. Right? The tangent is what we're looking at here. Tangent is one of those really, really interesting ones because, well, it gives us quite a few options here. So when we look at this first one on the right again, so you can see how this is our tangent, right? We have our opposite over our adjacent. But because it's already kind of there, that math tells us that the cosine 60 equals our opposite x over 16. So all we have to do is multiply both sides by 16. We get 16 cosine 60 equals x. And that's what you guys would plug into your calculator, all right? And then you would just write down the answer there. So, not tangent, not cosine, guys. Oh, sorry, it's tangent. 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 My bad about that. So 16 tangent 60 is going to come out to 27.71. 28. And again, it's probably going to say something about rounding to this one. So we're going to look at that one, make a decision. So 27.1 is our other side here. Now we can plug in the Pythagorean theorem and solve for the hypotenuse if we so desired. Now to use the inverse of the toe apart, again, we're going to use that opposite over the adjacent. So right now we know this is 2/6. So what I'm going to do is I'm going to hit that second button on my calculator, and I'm going to hit second and then cosine, oh, there I am again, tangent, which should pop up a display that looks something like tan minus 1. And we're just going to plug in that fraction that we have, and that's going to give us the final answer. So when we take a look at that inverse here, we're going to go second tangent 2 divided by 6, end parentheses, and we come up with 18.43 degrees as our answer. Now if they tell us to round, we're going to see that, and we're going to know right away that it's 18.4 degrees. That's our final answer. All right, so hopefully this helps you guys and kind of gets you guys rolling with this stuff this week, and we're going to work through this. We're going to do kind of a mastery check on Thursday, check for understanding. Big deal there. Want to make sure that you guys are grabbing this before we start looking forward. Again, my role is to make sure you guys understand it, not to keep pace. So if we're going slower than the regular geometry classes, don't fret, we'll be fine. All right, thanks for watching. Take care.